Chapter 3.4 exercises 13 through 22. This section 3.4 deals with, again, properties of logarithmic functions. In the previous video lesson, which had exercises 1 through 12, we went over taking a single logarithm and separating into two. In exercises 13 through 22, we're going to take separate logarithms and combine them into a single logarithm using the same rules, but we're going to be going the other way. And so here we have the logarithm, which is the common log, and when we say log with no subscript, we really mean a log base 10. So that's one thing we'll have to keep in mind. Now what we're doing here is the very thing that enabled logarithms. The adding, subtracting logarithms is what empowered slide rules, and that would be the pre-mid-70s technology for multiplying and dividing without a calculator a long time ago. Anyway, the principle is if we have a log, a product, the log of a product like log x times y, that is equal to the logarithm of x plus the common logarithm of y. And so we're going to be going backwards from here. So essentially what we're going to be doing is we're going to rewrite this as the common log of x times y. And you could put that in parentheses just to make certain we know that that's what we're talking about, the product of x and y. Again, going backwards to make a single logarithm. Problem 15, we have the natural log, and natural log, which we put ln, is equal to log base e, right? So again, this is going to be we can rewrite these two logarithms, a difference as the natural logarithm of y over 3, and we can put this as a parentheses to make sure that we're talking about the quotient here. That's really all it is to it. We're going backwards. Next problem, 17. We have 1/3 of the common logarithm of x. The thing we need to know for this one is that if we have a variable or a number to the power of a fraction, like say 1/4, that's the same as writing it in a radical form as the 4th root of x. So radical to rational. What we have for this one, we have this 1/3 coefficient out front of the logarithm of x. What we need to do is take this 1/3 and put it up here as an exponent to x. And so this is going to be equal to the common logarithm, log base 10, of x to the power of 1/3. And changing our rational here to radical, this will be equal to the common logarithm of the 3rd or cube root of x. So that's going to be all it is. Again, changing radical to rational form, that's a key skill here. And then also the coefficient in front becomes the exponent of the argument. So let's go on to the next odd number problem, which is 19. We have 2 times the natural log of x plus 3 times the natural log of y. Well, for this coefficient out front, like we did in problem 17, becomes the exponent of the variable x. And likewise, this 3 out in front, the coefficient in front of the natural logarithm of y, will become the exponent of the variable y. So what we have here is the natural log of x squared plus the natural log of y to the third power. And now we can rewrite this sum of two logarithms as the single logarithm of a product of these two logarithms. So we're going to write these two logarithms as the logarithm of the product of x squared and y to the third power. So that's really all there is to it. Next, we have 4 times the common logarithm of xy minus 3 times the common logarithm of yz. And so what happens in this case, this coefficient of 4 out front becomes the power of x and the power of y. And likewise, this coefficient 3 out in front of the common logarithm of yz becomes the power of y and also the power of z. So it's kind of like distributing the exponent, if you will. So we can rewrite this as log, common logarithm, of x to the 4th power, y to the 4th power, minus the common logarithm of y to the 3rd power, z to the 3rd power. And now we have these two logarithms, and they are differences of each other, so we can rewrite this as a single logarithm by taking the common logarithm of, we need to leave ourselves enough room here. We're going to have x to the 4th power, y to the 4th power, over y to the 3rd power, z to the 3rd power. Okay, and then we'll see if we can do any simplification here. Now, in the numerator and denominator, the thing we have in common are y's. And for that we have, if we have y to the 4th divided by y to the 3rd power, which is what we have here in the numerator and denominator inside this logarithm, we're going to end up with a single y in the numerator. Right? So our final simplification is going to be x to the 4th, y, and then we've already canceled out this y in the denominator, it's y to the 3rd. So the only thing we can have left is z to the 3rd power. So that's going to be it. Anyway, this concludes our exercises on taking logarithms and combining them into a single logarithm. Good luck on the even number problems, the demonstration you're learning, and thank you for viewing.